and we will record this session. So if you have any questions, you can just key in to the chat box, or you can unmute yourself. We have kind of only a few people here in online. So yesterday, we talked about the data wrangling. Mainly, we use the two packages. One is dplyr and another is tidyr. Here is the functions we talked yesterday. Select and filter, we use these two functions to subset a data frame. And mutate, we use that to create new columns based on existing columns. And group by and summarize, we usually use them together. We can use that to split the observations by a specific categorical variable and do the calculation, do the analysis, and then we combine the results. Arrange, we use that to sort the results and count. That's very self-explanatory. Beyond this, we also talk about operator, pipe operator. We use pipe operator to connect data frame with functions. And also we use that to connect functions. So we can use this pipe operator to send a data frame to a function. And also we use the pipe operator to send the result of a function to another function. So if we have multiple tasks on the same data frame, that's very convenient and easy to read. We also talk about tidyr. We start with the tidy data, 3 principles of tidy data. Each variable has its own column, each observation has its own row, and each value has its own cell. In tidyr, the 2 main functions are pivot wider and pivot longer. We use these pivot functions to reshape the data between wide and long. Long and wide formats. And in our own data sets, we use the pivot wider to reshape our data. We split the column has multiple values and make each value a column name, so we can easily calculate the items owned by each family. And also, we talk about export the results to write them into a CSV file. So that's kind of what we covered yesterday. Today we're going to talk about data visualization. So we're going to use is called ggplot2. It is also a package in the package collection tidyverse. So ggplot2 is the implementation of grammar of graphics in R, and GG means grammar of graphics. So in the package ggplot2, all the graphics are built using a layered approach. So layers are built up one by one to create the final graphics. So there are 3 basic components or 3 basic layers in ggplot. This kind of must-have layers. The first layer is data. That's the data set we're going to plot. And the next layer is mapping, aesthetic mapping. And that kind of describes which variable we're going to plot and how the variables are mapped onto the graphical attributes. It can include something like axis, y-axis, the color, and the shape. And that's the mapping layer. And another layer is geometric objects. That kind of determines the chart type. Let's say how those values are rendered graphically. And we can use bar chart, scatter plot, line chart, or other type. And using ggplot, the function we are going to use is called ggplot. The package is ggplot2. The function is ggplot. So we mentioned those three basic elements, three basic layers. So this is kind of the template we can use to organize these three layers. The first layer is data. So we put our data frame here. And the next one is mapping. We use aesthetic AES function to put all the mapping elements in this function. And the next one, well, geometric objects, we just call it geom function. And also we can use the pipe operator to send the data to the function ggplot. And the first layer is the mapping, and we can use plus to connect different layers. So we use pipes to send data to ggplot, and we use plus to connect layers, to add new layers. For the geom function, if we want to create the scatter plot, the function we're going to use is geom point. If we create a line chart, that's geom line, bar chart, geom bar, and box plot, that will be geom box plot. So now we can start the coding. I think you must have received my email. Download the starfleet.zip file and unzip it to your computer. And then still the same, we are going to click starfleet.r project to start the session. So for data visualization part, we are going to create a new script. So click this plus sign and R script. So today we can add some information, say title, data visualization, and then we can put other information and today's date. I think you already have the tidyverse package installed. And but first thing first, we need to load tidyverse. Next, we're going to use the read in the data we created yesterday. So that will not be the data, the original data. This time we're going to use the data, the interviews plotting. So still we're going to use the function read underscore CSV, but this time the file we're going to read is data output / interviews underscore plotting .csv. We need to assign it to interviews plotting, and we use this assignment operator as alt minus. We run it again, the new object shows up in the environment tab. You can click to see how it looks like. We know it has 131 observations, and also it has 45 columns instead of 14. We can score to the most right, and we saw those items of people own, and we also see the months and none. This is for those families who don't have any months lack of food. And we also see these two columns. One is number of items this family owned, and another one is the number of months they lack of food. So first we can save this R script file. We can put it under scripts. We will name it as core data. And then you can see it here under the scripts folder. So now we are going to start our first graphic. So the data we're going to use is interviews plotting, and we use pipe operator to send it to the function ggplot. Data is the kind of first must-have component, but first must-have layer. When we run this, we will see it opens the plots tab, but we see only a gray background. We know the data, that's the data we're going to use, but we didn't specify how we want to map it and what kind of charts we want to use. So it only shows the gray background. Now we're going to add another layer, that's the mapping layer. The function we're going to use is aesthetic. And this time we will specify the x-axis, that will be the number of family members, household members. And then the y-axis, that's the number of items. So we can control enter to run it again. So this time we can see the x-axis and the y-axis are set up. So x-axis, number of household members, and number of items, that's the y-axis. We still need to specify what type of chart we want to use. So to connect this layer, we need to use the operator plus, and then you can say geom point. We want to create a scatter plot. So then we run this, and we see all those three layers are kind of put together. We have the x-axis, y-axis, and also we have those dots. here, this ggplot2 function, those can, all the layers after that can see the information here. So each geom function can have its own aesthetic function, but this is kind of the local aesthetic setting. And this aesthetic setting is a universal one. We will see examples later. And the plus sign, we can only use it at the end. Okay, we can, if we put it at the front, run the function, we will see an error message. The same as the pipe operator. If we run it, we will see an error message. So we can put everything in one line. It will run normally. We can clear this, and then we run this command line again. We see the result. We put them into different lines to make it easy to read. This also works. But we could not put the pipe operator or the plus sign at the very beginning of the line. So this is our first plot. And if you have any questions, just let us know. Typically, when we build plots with ggplot2, usually it's iterative process. So let's say, okay, another title, and then we can start.
So we have a question asking the code is not working. Can you talk a little bit more about that?
Okay, could you give us more information? What's the error message? Or you can put your code in the chat.
I think he's trying to get it. Yeah.
Since your kind of codes along, most of the time that's the typo.
When you're ready, you let us know. How about that? Oh, it worked.
Oh, okay. Okay. So we will move forward. And so look at this chart. We know we have 131 rows, it must be 131 dots on this chart. But it doesn't look like it has that many dots. So we know the x-axis and y-axis number of household members and number of items that each family owns, they are whole numbers. So higher chances they overlap to each other. So that's why we did not see over 100 dots. So to kind of solve this problem of overlapping problem, and there are basically two methods. The first one is we can add some transparency to these dots. So some dots will look lighter, and if they have overlap at the same spot, it will look darker. To add transparency, we can have the argument alpha. We can set alpha equals to 0.5, kind of right in the middle. If alpha is between 0 and 1. If it's 0, it's totally transparent. If it's 1, it's just solid. So we set 0.5. Now we can see some dots looks lighter and some looks darker. A little bit, but not a lot. So we can try the second solution, which will kind of move the spot, move those dots a little bit away from its original spot. And then so we can see kind of scatter of those dots. So the geom we're going to use is not geom points, that will be geom meter. So we can start. This is the data, and we send the data to bot, and we will define the method. X equals to number of household members, and Y equals to the items they own. And the plus sign, we will add the geom layer, the geom meter. So you can see all those spots kind of scattered a little bit across its around its original spot. For geom meter, we can also use the transparency. So this is kind of overlap. 3 dots, 2 dots here. Here, it also allows us to set kind of how far away it's kind of away from its original spots. We can use the argument width and height. By default, the width is 0.4. The height is the same, 0.4. But this time we want to try a different number. We try to make a smaller. Oh, I forgot the comma after the alpha. Okay, so it should work, and kind of closer than before. And put it again. This kind of scatters a little bit more. If we set 0.2, it is the getting closer. If we set them as 0, that will be overlapped, totally overlapped. The width and height, they are from any number between 0 and 1. And we can also add kind of assign them different colors. Let's say we want it to be blue. We need to put blue in the quotes. And we change the color to blue. You can change to any color, red. You can also color them by categorical data. Let's say we want to color them by village. We know we have 3 different villages. And if we want to color 3 different villages differently, we can use the color equals to village. But we need to put that into the aesthetic function. So that's colored differently. This aesthetic function is locally to this geom. If we add other layers, it won't impact other layers. We can also add another layer. Let's say we can add trend lines. Say trend lines, we will use the geom smooth. And we will create, let's say, linear regression, LM. So we use plus to connect those 2 geom layers. So we see this trend line. This is a trend line across all those observations for all those 3 villages. If we want, they kind of separate. Each village has their own trend lines. We can add same kind of this aesthetic color equals village. So this way we get 3 trend lines for different for these 3 villages. So this aesthetic color equals to village is locally kind of for this geom smooth only. This one is for geom gitter only. Since those 2 layers, both layers use the same aesthetic element, we can move it to the global layer. So we move color equals to village to the ggplot layer. From those 2 geom functions. And let's clear it. And then we run it again. We see the same results. So for the aesthetic elements, we can put them on specific layers locally, and we can also put it on the ggplot function that will be universal globally. Any questions? We just mentioned kind of two methods to solve the overlapping issue. There's another one we can use. Say, plus sign to connect geom layer. This time we are going to use geom count. So we can see the size of the dots different. It shows the how many original dots are there. We can also add the kind of the color information. So it will show different colors and size for different village. We just saw the scatter plot. We will talk about other plots. Next, we're going to talk about the box. We use box plots to show the distribution of a variable. We still start from the data and use Control Shift M. That's the type operator. Send it to ggplot. And this time, we will use only y-axis. Sign to connect geom box. If we use X, it will be kind of turn 90 degree, so in another direction. So this is the box plot. The line in the middle, that's the medium. And this line on the top, kind of above, that's the 75th percentile. And this lower line, that's the 25th percentile. So this box is kind of like the interquartile range. And this width, that's the 1.5 IQR, and this is the same in another direction. And this dot is the outline.
So they're asking how to name every graph. Can you be more specific? Like, you want to name this graph itself instead of just having like the X and Y axis named? You want to have a title? Is that what you're trying to ask? Yeah, a title.
Okay, so we will talk about title later. We can add labels to this graph. So we will get there later. So now we see the box plots for the entire data set. And also we can display them by village. And we can add the, okay, let me copy it and create another. So we can add x equals to village. And when we run that, we will get 3 box plots for 3 villages. We can tell that this our village, people in that village, they have more items, they own more items than the other 2 villages. So in the previous example, we saw the scatter plot. We saw all the dots, where those dots are. And here we just see a box. We can also kind of put them together. So we can add another layer using the geometer. And then we can see all those dots comes back. Sure, we can add those alpha information. With for the layers, mentioned we add one layer on the top of another. We can reorder the layers, but we will see different readouts. If we put the box plot over the header plot, we will see all those dots behind. Those dots kind of overlapped and we could not see that. So the layers, we have to arrange those layers. That does matter. Another commonly seen chart will be bar chart. So we use bar chart to visualize categorical data. So how to create bar chart. We still start with our data. So shift and send it to ggplot. For bar charts, we need only one. This time we can use respondent for type. That's kind of another categorical data in our data set. Geom bar. So this way we see we have 4 different types of the response of the form. And our chart will put the counts in each category as the height. Always see that. We can also kind of color them by village. So we can add and for the spelling, we can use the US spelling. We can also use the UK spelling. All of them are acceptable. So we use color equals to village. We see it change only the border. It doesn't really change the bar. To change the bar, instead of using color, we use fill. So that will change the bar. So this is kind of the stack bar chart. And we can also create kind of bars side by side. This time we want to do the side by side. We can add another bar side by side. So this kind of looks nice. And we have different, we color them by their village, and we have the bars for the by their war type. And we know for the sentiment, we know we have only one respondent, one family, the war type is sentiment. We can exclude that. To do that, we can make we can filter this observation out. That we will use the functions we learned yesterday. Still, we send it to, instead of ggplot, we send it to filter. We filter the respondent war type equals to segment. That will kind of limit to only the segment. We will have only one element, one observations, one record in the data set. That's not what we want. We want to exclude that. We use the exclamation to kind of exclude that. Say we can set it to view. So here we know instead of 131 entries, we have 130. So that one sentiment one is excluded. If we send it to this bar chart, let me see. Okay, instead of this, and we should use the plus. I forgot the GG plus. Okay. This will still be the type operator and send it to GG plus instead of Geom. I forgot, I missed the one line. And then if we send it that segment is gone because we filtered that out. Sometimes we want to kind of visualize the proportion, the percentage of each village or of each ward type. So we still can do more on the data part before we send it to the ggplot. Let's say we can count the village and respondent ward type. And then we send it to group them by village. And then we can add a new column percent. We use n divided by the total n. Then we can take a look how the data looks like. So this is currently the data looks like. We have the column village and respondent ward type, and that's the count. The number of observations by village and respondent ward type, and we calculate the percentage. So when we total this percentage, that will be 1. That will for this CH village. And this is for the God village. That's total percentage is 1. And this total percentage is 1 for this R village. So we can kind of process the data before we send it to the ggplot. Since we already have this percentage, and we can add y equals to percent. I think we just move by village. If we make this X village, I think we should make the fill respondent more type. Kind of switch. And let's run it. Nothing shows up. There's some error message here. Because Geom bar, it will do the it will display the bar, the height of the bar is the count. But now we want to display percentage. So we need to add another, we need to kind of set another optional argument, which is stat. Instead of using the count, we set it as identity. That will be the value of whatever we calculated. So this time it comes back. if we want to make this bar chart looks better, we can add some labels. We can rename labels. We can add titles. So we add another layer, the plus sign. It's just called label. And we can title to proportion. We can reset the x-axis, y-axis, and also the legend. Fill, that's the legend part. And footprint. And also x. Village. We want to capitalize V and Y percentage. So this time we have the title of this chart. And also we kind of make this x-axis, x-axis, and y-axis. Like the percentage of the wall type by village, we still put them in the same one chart. We can split them into multiple charts. The function we're going to use is called facet. So we're going to talk about facet. So it's still okay. We can copy everything from here. And another layer. That's it. And this one is shift delta. Tilde. So as we do the, I think we can do a little bit more information. We can remove the color thing. And also we can yes. So this time we have this different wall type as the x-axis, and kind of we faceted by village. We just add the kind of the title and customize the y-axis, and we can also, I say that, customize the look and feel. The background currently is gray, and we can, ggplot offers some theme. We can use the black and white theme, black and white, to remove the gray background. We can also use theme to control the font size or other things. We can use a simple one. Back side of the if we kind of like this, this chart, we can save it. So we can create another folder to save our output graphs. And the same as yesterday, we can use the command dir create, and we will create a folder called here. And the function we're going to use is ggsave. First, we will specify where we want to save the file. And forward slash, we will call the file, let's say, myclass. And that will be the output of this one. Sign it. Operator. Control enter to run it again. So we can see my plot listed here in the environment. And now we use my plot. That's the object name. So we save it as this size image. We can take a look. Here, this is the plot we just created. And we can open it and see, doesn't look good. We can set the size of this file, so to make it look better. Okay, so we can set, let's say, width equals to 50 or height equals to 10. It will use your kind of the device unit for the graph. Right. This looks much larger. Now it looks better. So we have our the chart output. About customization, I just mentioned ggplot. ggplot offers a lot of themes. We can never exhaust that. If you're interested in making your graphs looking better, making your charts looks better, you can look into the themes yourself. That's kind of all for the visualization part, ggplot2. If you have any questions, please let us know. Okay, so takeaway from the day, I think the most important thing is ggplot2 use the layered method, layered approach to create visualizations. The fundamental components of those layers is data and mapping and geom. And we kind of see the scatter plot, box plot, and bar chart. We also talk a little bit about the facets, so you can create multiple charts. And also in the guide, we have the cheat sheet we already seen yesterday. So the first one is for ggplot2, and you can see different geom and how to create different charts. Geom column, that's kind of similar to geom bar. And for the box plot, and if you can have violin, it looks a little bit different than the bar, I mean the box. So it's difficult to know all those functions, to remember all those functions. And we also have something on the guide, our graph gallery. That's the website that offers our code. Let's say we talk about the box plot, and yeah. So that's the box plot, and it explains the different, the kind of how the what it is, explains the box plot, and then it shows you the difference. This is the very basic version, and this one we already made that. We have the scatter plot on the top of the box plot, and this is the violin chart. Kind of shape them differently, and they have all those examples. If you want to create box plot, let's say I want it to look like this, you can just click and then it will show you the code. So you can copy the code and use your own data. So let's say for this one, on the border, on the margin, they have the histogram, and this one is the distance. And this one is just the this is 3, 2. And you can see more customized version. You can add color. T2 is they have the color. This is the fill. And this one it displays only the on the x-axis. The density on the x-axis. Other only kind of data wrangling, mainly the data wrangling and visualization. And you could not cover all those functions. And if you have any questions, you can always use Google to search. And let's say you can search anything I want to combine my two data frames. And you put R at the very beginning, and then you put your question there, and then you may see different solutions listed. Let's try the first one. It will suggest you use the function merge. And so you can merge by ID. And also it suggests you use R bind. That's another function you can use to combine two data frame. You will try them to see their advantages and disadvantages. And yesterday, I think we used another function, combine two different data sets. The function we use is left join. And other resources you can use is Stack Overflow. You can put your question there. And the RStudio has a very good community. So you can always have your questions there. This is a kind of forum. And our documentation, this is where the original developers put the documents there. So if you have any questions about the functions or any concepts, you can find the answers from here. This is specifically for tidyverse. The library have the databases already, and we have the video tutorials already database. Here are these are kind of, I think all those have electronic version, if I remember correctly.
I know we had that first one and the beginning data science in R, but I don't know about the rest.
I don't think we have. Anyway, you can, if we don't have that, you can use document delivery to get it, to borrow it from other libraries. You put your evaluation here.
I dropped that in the chat, so if you want to use that real quick, that's fine.
Our contact information. If you have further questions, you can contact us.
Okay, I'm gonna stop recording.